Hello friends, this video on P block elements part 22 is brought to you by examfear.com. No more fear from exam. Let's talk about another important compound called silicones. Silicones are nothing but polymers which have R2SiO in a repeating unit. For example, this guy R1, R2, this 2R2, SiO in a repeating form, N form, right? This is called silicones. We will study more about this in the organic chemistry, but just understand the silicones. It has to be in R2SiO repeating unit. There are two R's. It has to be equal actually. Here both are methyl. If it is ethyl, both has to be ethyl, right? So this has to be equal and SiO and has to be repeating. And it will be, there will be two different compounds here. This can be R2 and this can be R3. It can be different also. But these both has to be R. Correct? It has to be repeating actually. Example, this is also repeating actually. You see this part of this. So this is my methyl group and this is something else. So what I'm saying is it is nothing but organosilicon polymer which have R2SiO repeating. So please note two things here. R2SiO group has to be there and it has to be repeating. See the N here? It has to be repeating. Then only it is silicones. Correct? So it is named silicones and why? Because its formula is similar to ketones. Ketones, you know, R2CO. So since the empirical formula is similar to ketones, it is named silicones. Since silicon is important, right? Let's try to understand the preparation of silicon. How to prepare silicon? So the starting material for the preparation of silicon is aryl or aryl substitute silicon chloride. It has to be in this fashion. For example, if you put N is equal to 2, it has to be R2SiCl2. If you put N is equal to 1, it has to be RSiCl3. Something of that form. This is what we'll use here, right? So this has to be in this form, right? Whereas R is an alkyl or aryl group. It has to be methyl, ethyl or aryl group. It has to be in this form. That is the starting material. So let's first prepare this starting material. How to prepare this starting material? So you take this CH3Cl, you add silicon. Copper powder is a catalyst at 570 Kelvin, you get this. Example, if you see, this is something which we are looking for, right? This is R2, R is here methyl, R2SiCl2, right? So once I have this one, and this compound name is dimethyl dichloride silicane or dichlorosilicane, dimethyl dichlorosilicane. So once you get this, what you do is you do hydrolysis of this. So once we are done with the hydrolysis, then you do condensation polymerization. So we'll learn more about this in the hydrocarbon chapter. If you don't understand this, just think that something like this exists, and we'll understand more about this in the hydrocarbon chapter. And this will be the chain polymer. So the first thing was we have to get this aryl or aryl substituted silicon chloride. This is silicon chloride, right? So I have got this silicon chloride. How I got the silicon chloride? I got this CH3Cl, in that I added silicon. Copper powder was the catalyst, 570 Kelvin. I got this aryl silicon chloride, and this is dimethyl chlorosilicane. And once I have this, what I am doing is I am doing a hydrolysis. So I am doing a hydrolysis. I am adding water molecule and moving this chlorine molecule. So what I am getting is, instead of chlorine, I am getting now OH, right? Because I am doing hydrolysis. Hydrolysis is nothing but you remove the chlorine or any halogens with OH. So I got this. Once I got this, I am doing a condensation polymerization. So if you see, I am doing a condensation polymerization and I get this. So this is the process of getting silicones. Silicones, as I told, has to be in this form, R2SiO in a chain group, in a what you call multiple of this has to be there with some RR here. Correct? So to get this, the starting material is my aryl or alkyl silicon chlorides, right? Just to get that, first I am doing is I am getting CH3Cl, right? This is methyl chloride. I am adding with silicon and this 570 Kelvin. I am getting this aryl chloride. This is dimethyl chlorosilicane, right? And once I have this, I am doing a hydrolysis of this, removing the chlorine molecule and with OH molecules actually, and then I am doing a condensation polymerization. Correct? And the chain length of this can be controlled by adding CH3SiCl with blocks at the end. Let's understand the uses of silicon. The first is since it is surrounded by non-polar alkyl groups, so it is water repelling in nature, right? So it is non-polar alkyl group we have seen because it is something like this: R1, R2SiO, and there you have R3, something like this, right? So in this case, all non-polar alkyl groups, so they are water repelling in nature, and they have very high thermal stability, and they are used as sealant, grease, and for electric insulators. And they are also used for waterproof fabric because they are water repelling in nature, right? So they are used for water fabric, and they are also used for surgical and cosmetic implants. So sometimes people get this nose surgery done or the surgery of other parts. So since they are biocompatible, so they are used for surgical operation also. Let's talk about another important compound of silicon, that is silicates. So what are silicates? Silicates are nothing but solids with silicon oxygen bonds. Please note, silicon oxygen bond has to be there, right? And a large number of these silicates exist in nature. Example: feldspar, zeolite, mica, asbestos. We'll discuss more about zeolites in the next slide, right? So if you see, the basic structural unit is SiO4 4-. So if you see, all this oxygen has negative charge. So the whole thing has -4 charge because there are 4 oxygen, and this is the shape in the tetrahedron fashion. The most important man-made silicates are the glass and the cement. They are the man-made silicates, and these silicates are classified into various shapes actually. Orthosilicates, we have something called pyrosilicates, we have cyclic silicates, we have chain silicates, we have sheet silicates, and we also have 3-dimensional silicates. So we'll not discuss the structure of these silicates, just understand that these are the different structure of silicates available in the nature. As I told, we'll discuss about zeolites. It's nothing but a type of silicates. This is the shape of the zeolites actually, you see, and these are microporous, and they're normally used as absorbent. They also use for filtering stuffs also. We have discussed, right, in the last chapter where we talked about the softening of water, where we have used zeolites to purify water, correct? So if the aluminum atom replaces few silicon atoms in this, the overall is called aluminum silicates. And these zeolites are also used as catalysts in the petrochemical industry, and also used to convert alcohols to gasoline. And sold, these are also used for ion exchangers in softening of hot water. This is something which we have discussed in the last chapter where we talked about how to soften the hot water. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.